going to talk about, we have a specific term called CAL, Computer Assisted Language Learning, when we talk about language learning. But we also have CAL as a general term, Computer Assisted Language Learning, without the last L. And we have e-learning. The moderator was talking about e-learning, and e-learning is a broader term related to computer-assisted learning, but specifically on online assisted learning. And a topic specifically I'm coming with is blended learning. Blended learning has different features. We have the web-enhanced feature. We have the blended feature. The difference is in the web-enhanced, the amount we include in the learning is lesser than the blended. But we have also a related word. I don't see them different, but in different literature, blended and hybrid learning are interchangeably used, but in some cases differently used. In hybrid, indicating a larger amount of online learning, makes it into the usual face-to-face learning. Blended learning with a lesser amount. But personally, I don't see them different. And we have also another version, which is flipped classroom. What happens in the classroom may happen at home, and students come in the classroom just to discuss some ideas. So it's flipped because what has to happen in the classroom is going on at home, and students come into classroom just to share ideas with facilitation of their teacher. And we have ODL, and open distance learning, a fully online kind. So why are we relating listening and blended learning? You know, online learning can enable us provide a lot of texts, especially listening texts, that we can use for classroom learning. That's why listening and blended learning has to relate. And Moodle, that's the course management software, or sometimes called the learning management software I'm using for the experiment I did. But generally, what opportunities did I see, and I wanted to experiment? We have some opportunities in Ethiopia. This is the existence of ETN. The Lalam was talking about that, and there was a panel discussion yesterday, and in the panel discussion they were talking about Internet, Ethiopian Education and Research Network, about increasing the capacity of Internet in Ethiopia, especially in education and research. And teachers are now coming with the progressing ICT skills. Students, more so. And we are having digitized classrooms in our universities with some interactive boards and LCD and some laptops, all those in a classroom, and internet connectivity, obviously. And abundance of mobile devices now is making it easier for integrating e-learning into our classroom. But what is unique about the study I did is made for students with limited e-skills. They were not proficient in computing skills, as I observed them, and as I did the questionnaire, they were not that. And knowing that, predicting that, it was produced considering their skill. And gave room for student control over content of learning, which I will talk about it later, and used all the open source Moodle and integrated online learning with teachers' face-to-face feedback. Out there, we talk about computer-assisted language learning, e-learning for long years. But when you come to Ethiopia, I don't think we have really harnessed that into the benefit of improving the quality of students' learning experience. So that's why we need to find the case. Does it work in Ethiopia with the limited skills we have and maybe the limited resources we have in Ethiopia? Generally, I had two objectives. That is to test if face-to-face teacher-led feedback integrated with online students-controlled listening tasks and texts enhance English language listening achievement, and to explore if students' attitude to involve in online learning of listening skills significantly improve after their involvement in blended listening lessons. The hypothesis is there. I had pairs of hypotheses for each, but I want to tell you the design and the methodology of the study. What kind? It was a quasi-experimental study. Why I called it quasi-experimental, I actually took an intact group, a class as it is, without modifying, without resectioning. So I took the sections as they are, and that's why I'm calling it a quasi-experimental. What samples? It was a random sampling in the sense that there were 5 sections. Among the 5 sections of computer science students, I took 2 randomly, and again randomly made them experimental and control group. What tools did I use? I used tests, pre and post test, questionnaire, close-ended kind, pre and post, open-ended questionnaire, and focus group discussion. The materials were the course material itself. It comes from the Communicative English Language course. That's a common course given across the universities, and I have taken this course, and from the course I have taken the listening section of the course and just e-coursed that, or change it to an e-learning course. And analyze, how did I analyze the data? I used quantitative SCPSS version 20 for the quantitative, and I used the thematic analysis for the qualitative. The materials, we have an e-learning portal in my university. You can access it from elearning.amu.edu.et, and students need enrolling. They needed a password and a username, and this was given by the researcher. I had to list all the students, give them username and passwords. Passwords could be changed by the students, but anyway, that's the way it was done. And accessing, what did the students access? They accessed the pre, the while, and the post-listening tasks, and again, the listening texts. Audio, video, and as well there was 2 quizzes, and they could access those. And how they could read the tasks online or download them. They just download the listening tasks and read them, or they can read them just on the screen. Listening texts as well, they were downloadable. And this is to show you what the contents were. And where they were and when, actually it was only in the language lab, because I wanted to control the experiment, but they were able to access them everywhere. The variables, the model and the concept of the blending. The variables, the independent variable was e-blended listening lessons, and the dependent variables, achievement and attitude. And there were intervening variables as well. The concept of blending in the study, mainly the online learning blended with the face-to-face, but there was also other blendings, like blending of space. Classroom, computer lab were there, and again, the feedback was given in the classroom, so a blend of space was also there. And a blend of materials as well. Desktops with headsets and notebooks. Here is where I have considered their skill. If I ask them to write using their computer, they need that skill of writing, using the keyboard, moving the mouse, and all those. So what I did was, rather, instead of writing their answers on the computer, they could take the answers on their notebooks. And integration of learning resources in the study. If you are interested, you can see that later. The procedure, there was an induction before I gave them the pre-test and as well the attitude questionnaire, and after that there was induction. The induction was about how they can use, they can access the e-learning resources and using their username and their passwords. And that was a simple training they were given. I better call it induction. And then the other procedure is simply a procedure that I used. I gave them the pre-test, then the pre-questionnaire, then the intervention came in the middle, and in the end, the post-test and the post-questionnaire. Okay. Piloting was done just to check how the tools can be used for the purpose, and then I just lead you to the results of the study. A two-tailed independent sample t-test, statistical values from the pre-test, mean difference between the control and the experimental group was the t-value, as indicated, degree of freedom, and p-value, 0.989 at 0.05 level of significance. Since p-value is greater than 0.05, there was no statistical difference in the achievement test before the intervention. And pre-intervention ICT training and e-learning experience was checked, and most of them didn't have that experience and the necessary e-skills. And then I have to check the effect on of the blended listening lessons on the students' achievement. And a two-tailed independent sample t-test for the equality of means was conducted, and the achievement mean difference between the control group and the experimental group now became significant. That was statistically proved. And that means that the null hypothesis was rejected. That means there was no significant difference in the mean score of the students' listening test result in the BLLS, and the counterparts in the face-to-face was rejected. Rather, the alternative was accepted. And in terms of attitude, there was no significant difference from the pre and the post-intervention. Their attitude remained the same. I'm rushing because the moderator is telling me that I have to. But qualitatively, the attitude was checked, and they happened to be positive about the approach, both from the open-ended attitude questionnaire and responses from focus group discussion indicated that. To conclude, the experimental group achievements were found to be statistically significant. This revealed that BLLS was blended listening lessons were helpful in improving students' achievement of listening. And the attitude scale result did not show a significant difference. However, the qualitative responses show positive attitude. Even if the students' e-learning readiness was indicated to be not satisfactory, they were observed to perform all the online blended listening lessons. However, a more comprehensive e-readiness study may be required to get a full picture. Thank you.
Thank you. Can you have a seat in here?
Okay.
All right, thank you. Someone? Yeah. Thank you, Dr. Tesfaye. Let's open the floor for Q&A. Maybe we can do 2 or 3 questions, depending on the time. So first question.
Okay, thank you, Mr. Chairman. I just wondering about the significance of your study. I think in your hypothesis, you say that you are just aimed to test if face-to-face teacher-led feedback integrated with the online student control is important or not, I think. But in your literature, you have also said, hello. Computer-assisted language learning call being concerned with teaching and learning of second language through computer technology has become an important tool in enhancing language learning. So do you think your study is significant? Thank you.
Why don't we take another one? Any question? Well.
That's a very good question. That's a very good question. And yes, in the literature, it's indicated that computer-assisted language learning is beneficial, but not in a low-resourced context and not in a low-skill context. And so we have to check if it actually works in such a situation. And that's why we need to make a case. Probably, we are not accepting e-learning in a way we wanted in Ethiopia because we are not sure whether it works in Ethiopia. And so we needed cases like this, working cases like this. And that's the possible answer that I can give there.
Any more questions? Well, how about if I ask you? I mean, it's in developing countries, the jury is still out. There is a lot of research going on the efficacy of online teaching, whether it is blended or not blended or pure, whether it is synchronous or asynchronous. And what do you think how can we leverage e-learning, especially given the challenge of faculty shortage in Ethiopia? Do you think that could be one possible intervention to address that problem?
Yes, it can address especially shortage of people. We have been talking about quality yesterday, quality and e-learning. We were talking about e-education. We were talking about. And maybe if quality can intervene, it's in this way that it can be explained. Like we can have expertise somewhere, very good expertise, and if we want to use the expertise, these quality people out there, what we have to use the ICT, because transporting all those quality individuals from one place to another and paying all the per diem and all those might be so expensive. At the same time, using that expertise might be difficult, and the interest of the individual traveling all the way around might be really difficult. So using technology can really assist. For example, we were talking about e-conferencing and all those yesterday, and then the person in Aberdeen University who is really good at water technology can teach students at Mekelle University or the vice versa. And then we can talk about quality. It can also help those shortage of qualified human resources as well.
Thank you. Any more questions? If not, then we will move on into the next topic. Dr. Tesfaye, thank you very much. We appreciate it. Next one is it's a review on 5G promising technologies and their critical challenges. Mamacha Shankrapa. There was a very interesting discussion this morning on the promise of 5G, where we are now in Ethiopia with third generation, fourth generation. But given the increase in this tremendous uptake in IoT and other things, fifth generation of communication is becoming big in the West. And Shankara, I guess if you can introduce yourself and then take it from there. Thank you.
Sorry. If you could give me a little more time, you know. Good afternoon to everybody. I'm Mamata Shankarappa from Ambo University. I think you would have been noticed now, and my presentation is going to be the valedictory presentation. It was something in the middle, and this is what is ICT, you see. Starting with 5G and ending with 5G is a very nice conclusion what we're making today. And all of you have really presented a lot of primary data and real research. Mine is just an article. I just make it very clear. In the beginning itself, it is an article. Not much of primary research is being done because 5G is still at the very premature level to talk about any solid research to be done. So this is just a review on promising technologies and their critical challenges. Okay? As we know, not hearing? So what is 5G now? Let's just discuss what is 5G, because morning fellow author in the conference already discussed some points about 5G. Let us just take a look at 5G from a common person's perspective. I'm not talking from a very technical perspective. I just wanted even the common people to understand, because today the cellular technology is not just restricted only to the industries or the research centers. All of us are using. In fact, even the common people are even better in using the apps. That is what I've been observed. So what is 5G? 5G is an end-to-end wireless technology ecosystem to enable a fully mobile and connected society. This is a little bit sophisticated or a superficial definition, if I can define 5G, but 5G is yet to be standardized. All of you should understand it is not being implemented still. It is at a very premature level and not turned into reality. And 5G is the current industry and research buzz. Everybody talks about 5G, 5G, 5G. What is there in this 5G? That is what my article talks about, and 5G is creating a real evolution and a revolution in this incredible wireless industry. Now, let's just take a quick look at the evolution of cellular technology. As you can see, in 1980s, the basic mobile system was started, which was known as AMPS. This was just with the analog technology. Later in 1990s, the GSM technology was evolved with the gap of 10 years, and then 2.5G with an added technology into it, which is an edge technology. Then in 2000, 3G, that is third generation, started with another new addition of technologies, which are UMTS and HSPA technologies. Then, in 2010 again, with the gap of another 10 years, another 4G is being added into the pocket, which is HSPA and LTE. And finally, it's a time to talk about 5G. Again, with the gap of another 10 years. If this is the case, is it necessary for us to speak about 5G now? Because it's still a long way to go. We are in 2017. Why is that people talking about 5G, 5G, 5G? Because of the new technologies which have been added into this is what is making people to be more curious. And when you're taking a look at this slide, I also wanted you to notice there is always, from amps until 5G, if you can notice, there is an increase in the capacity, okay? So when you are seeing GSM, you can see 10 up to 100 kbps, and when you move to 3G, it is 100 Mbps. When you move to 4G, it is, 10 Mbps, and when you move to 4G, it is 100 Mbps. What is the speed that we are expecting in 5G now? The speed, exactly what we are looking here, is more than 1 GB. 1 GB up to 10 GB is the speed we are expecting. The society is becoming speed hungry, or we can call data hungry. Every app needs a lot of capacity. So now it is the capacity which takes a main role here. Is it only capacity? Somebody asked in the morning. Let's discuss about that also in the later slides. What is that 5G is offering for you? 5G wanted 1,000 times increase in the capacity, that is your traffic, and 10 to 100 times increase in your data rate, and support for 1 million connections per kilometer square. Can you just imagine this? We cannot even imagine this, isn't it? Per kilometer square, it will be promising to support, are planning to support 1 billion connections. It could be devices or it could be people to people. Then 1 up to 10 gigabits per second connections to end-to-end point. This is basically the latency, what I mean. And 1 million end-to-end round-up trip delay. This is specifically the latency. And also, everybody, those who are in the network field, I think you know what I mean by 99.999% availability. This is what industry is looking for today, basically. And let us just take a look at the promises the 5G is making. 5G promises to give services in broadband for massive traffic capacity, higher download speeds, spectral efficiency, and also a new spectrum will be added into this, and extreme density, massive user density, and innovative applications like creative use cases, new dimensional services, context awareness, and such things. The other side, it is also focusing on mission critical. What is this mission critical? In mission critical, we need a very low latency and high reliability and availability. And also, security also takes a picture here. And also, it is looking for battery life, means energy optimization and adaptive efficiency are also the points over here. And last but not the least is Internet of Things. What is Internet of Things? Internet of Things, I'll have a separate slide, you can take a look at that. But here the focus on Internet of Things is signaling reduction and billions of connections to be made, and low energy consumptions are the focus of 5G. So overall, it increases the efficiency, increases the capacity, increases the adaptability, and totally a kind of innovative cycle is being revolutionized. That is what is the promise of 5G is all about. Take a look at, majority of the slides are animated, are kind of graphic, because I'm also focusing on non-technical audiences. I want everybody to have an awareness on 5G. So let's just take a quick look at 5G vision here. It is planning to support in a place where 4G is a limitation. We have to always remember the higher technology comes only if there is a limitation in the previous technologies, isn't it? So now, so 5G is much suited in the places like ultra-dense, like the stadium, or in any of the gaming places, such place, and it is planning to give a broadcast, a public safety, it could be automotive, it could be e-health, or a mobility. When we talk about the mobility, one thing you all have to know is 5G is planning to give 300 up to 500 kilometers per hour is the speed for the mobility it is planning. So whatever, and also for telepresence. When I talk about broadcast, it is basically the telepresence what I just wanted to tell. To achieve all this, what do we need? To achieve all this, we need radio. I don't mean the radio, the device we buy. What I mean is a radio spectrum. We need radio spectrum. How do we get that? We get that through spectral efficiency. Is that enough? This also is a matter of energy. So the concept of virtualization is being taken into consideration, and spectral efficiency and energy efficiency are going to play a major role in 5G technologies. That's why I say here it's a union of spectral and energy efficiency. But do we have a smooth road to travel on this? No. Both capacity and power consumption are critical for 5G's success. There is a lot of hindrances which we need to really go through to achieve. I was just telling you 5G with IoT, they have great plans over here. You can take a look at this slide, you can understand. 5G along with IoT is planning for connecting the whole globe together, to say in simple terms. That's all I can say. And when you take a look at this, you can see it wants to connect through the Internet of Things, the real world mobility, and fourth industrial revolution, high performance infrastructure, and virtual mobility, etc., etc. And when we focus at real world mobility, you can see the augmented gaming and augmented shopping and augmented dashboard, etc., etc., have been focused. And when we talk about the fourth industrial revolution, I'm focusing more on automotive, but a lot more things are there. And when we talk about high performance infrastructure, it could be in the traffic, or it could be in the safety and security, or it could be in the utility and energy. And when we talk about virtual mobility, it is the travel and commute. Due to lack of time, I'll be going a little faster. So let's come back to the subject now. This is what is all about. I plan to talk 5G promising technologies. What is that? What is that? The current technologies, including the 4G we have now, have almost reached the technical limitation to assist 5G challenges. Now, new researchers have been already started beyond 4G. So hence, 5G is focused on new promising technologies to achieve its goal. And some of them only I'm listing it over here because my focus is on some of these things, that's why. So massive MIMO, millimeter wave, CRAN and virtualization, heterogeneous networks, device-to-device communication, and etc. are the promising technologies for 5G. Why 5G, isn't it? Because why do we need to take so much of risk of talking and doing all these things? Why 5G? As I told you, if there is a limitation in the present technologies, only we look for the new one. So now, let us view 5G from the operator's perspective. Okay? Please observe and just take a moment of my mouse movements. In the first left side of the diagram, I say it's increased capacity and increased OPEX. In that slide, you can observe, my mouse is also moving on the same side, please observe there. Where the mouse is pointing, we call it as a cell edge. And now, sorry, I'm very sorry. Yeah. Okay. This is called as a cell edge, and where a kind of chain is being made, we call this as, this is called as a cell peak, where I'm pointing the mouse, and where a kind of chain is being made, we call it as a cell edge. So there is a cell peak and a cell edge in every cell, and where the base station will be located. Near to the base station, we call it as a cell peak, and away from the base station, we call it as a cell edge. So what is basically the capacity decreases? How do we overcome this capacity? Decrease in capacity has to be taken into consideration. How do we do that? If you can observe here, also in the graph, if you want high traffic, then the one way of overcoming this is by employing more base stations. We need to employ more and more base stations. If we are employing more and more base stations, it is a matter of expenses. The expense goes very high. As you can see, this red color graph, which is showing the expenses. So if your expenses goes up, can you take this money from the end user? We don't want to pay any more money for cellular system. Rather, we just wanted to use only a Wi-Fi if that's the case. So what do? We need to plan for this, because the revenue comes down if we are employing more and more base stations. One is expenses. Another issue of employing more base stations is also an interference. So these are the two things we need to deal if we have to deploy more and more base stations. So to handle this, there is something called as uniform coverage. How do we achieve the uniform coverage? To achieve the uniform coverage, we have to employ base stations, but before to that, we need to find out where the problem is all about. I'm sorry, I could not even reach to the technologies, and my time is running out. Anyway, we'll try to just do as much as possible. 5G here, you take a look at this power consumptions. When we're talking about the power consumptions, if you can see the left side of the slide, you can observe here from 2G up to 4G, the power efficiency is being increased. So also when you see the other side of the slide, most of the expenses are going for the air conditioner. When we see the CapEx is capital expenditure, and when you see the other side, it is OPEX, operational expenditure. So when you observe this, we can understand that most of the money is going for electricity. This is what we have to care, and we're taking the devices which are there in the base stations, what do we call it as BBU, base station units, into the cloud. So cloud, we call in 5G as C-RAN, is one of the important concepts which we are taking in 5G and reducing our expenses. By reducing the expenses, we can achieve the things in a more better way. So now just take a look at the introducing technologies. Where is it introducing the technologies? It is introducing the technologies in the overall cellular system. It could be the backhaul, front haul, base station, the radio networks to achieve the good spectral and energy efficiencies. And there is a formula here. Just please take a look at this very quickly because I'm running out of the time. Otherwise, my intention was to explain all this. In this formula, what we can understand here is the signal bandwidth and number of channels needs to be increased to get the capacity higher. And also there is something called a signal to noise ratio. If there is time, I'll discuss this later. And you can take a look at the promising technologies, which are massive MIMO. Massive MIMO is basically you're adding more number of antennas than the end user unit. You have to understand here. And this exhibits a massive improvement over the traditional systems in terms of both energy and spectral efficiency. And also, massive MIMO is a combination of MIMO and beamforming, and it is also claimed to be energy efficient. Due to shortage of time, I cannot explain this technology. I actually wanted to explain and make you people understand. Just take a look at this slide. This is what is beamforming. If the time is being given or if there is any question from the audience, we can take up this and discuss. And the next thing is challenges on massive MIMO, because my paper discusses about the technology and the challenges. So these are the challenges I have listed also. And next technology is millimeter wave. What is millimeter wave? Due to the deficient of spectrum, we are going to add another unused spectrum, which is from 3 to 300 kilohertz. And in that specific range of frequencies have been chosen, and which we call it as the millimeter wave suitable for the 5G communication. Millimeter wave is also building a bridge between the 4G as well as your 5G. And one of the key features of millimeter wave is also antenna arrays. The challenges of millimeter wave is also being shown over here. There is some problem. I don't know whether all of you are hearing now. Next technology is device-to-device communication. In device-to-device communication, basically, it's a connection between two wireless devices directly or by hopping to constitute the communication. And in this, there are two types. One can be a global D2D communication. Okay, so yeah, the last one is a dense heterogeneous networks. The diagram explains that, and my time is over. I'm sorry.
Thank you very much. But you know, just to be fair to everybody, and we have time for Q&A. This is a very interesting.
This was told for 20 minutes earlier.
Okay, but I was told to do it only within 15 minutes. But when was that? Sometime in the 1980s, a scientist from MIT, I think, Max Weber, wrote an article which said about the end of computing. The end of computing is computing as we know it is coming to an end. You know, the desktop had become an obstacle to the new frontier of computing, and that's where what's called pervasive computing, ubiquitous computing, and what's called today IoT came into existence. And what is driving 5G is really this need for connectivity of not only humans to humans, but actually machine to machines. And what we have, the smart homes, smart vehicles, everything is smart. That requires connectivity, not only connectivity, also different ways of connectivity. And what Romata presented is the science, the technical aspect, with a very, very interesting topic, very big. As we move into the next frontier, everything is becoming our platform of computing. It's not only the computer that we have at home, now it's our device on our watches, our cell phones, or even anything that has capacity of computing. Anything that has an ability to function as a microprocessor is and will become part of our computing platform. Now I'll open this for Q&A. It's very interesting. She's got a whole lot of things that she could share. So I open it, and feel free. I'll start here.
Okay, thank you. My name is Mesfin, and I want to raise one fundamental issue. I know the content is very rich, and it will also give a very good background on 5G technology related issue. But considering the event what we have, it is a conference which actually produces a research output. And I was wondering, what is your contribution in all this to actually relate to the topic what we have? And most of the research are actually doing some sampling, assessment, and analyzing data relate to the local context and all these things. I was wondering what is your contribution rather than giving the theory and the background information about 5G. I'm not discriminating or putting some less content to the presentation. It is really useful. We need to actually know about the subject matter and equip ourselves so that we will be actually be handling it carefully and customizing it. But I want to know from you, what did you actually practically as a researcher contribute to this paper? Thank you.
Thank you very much. A very real question has been asked because my presentation as such has been incomplete at the facet. And yeah, because 5G is a future technology, there is nothing as such to get the primary data from any countries. Research has been happening. And with the existing resource in Ethiopia, definitely we cannot do something great. We all have to accept the fact that, especially in terms of technology. This is one thing. And the second thing, if you go through my paper, you will definitely understand the challenges of each technology. If you go through my paper, you can understand what is my contribution. I've discussed, actually this paper is to advocate the people, advocate the public about what is 5G and the technologies which have been used over here. And from the technical perspective, I've taken what are the challenges existing, and you please go through, whoever is being interested. My paper describes the challenges and also at what stage these technologies are there and how long it takes. It gives a clear idea about it. I think this answer is, I've answered your question, I think, isn't it? Okay, thank you.
Thank you, Dr. Naga. It's an interesting lecture notes. I can see that you make a literature review. So my question is, did you prepare it as a lecture note, or have you followed any kinds of scientific literature review method, such as, for example, systematic literature review? If you do that, then I haven't seen any kinds of method, how you are following such kinds of scientifically accepted literature review. My second comment, for me, it would have been really interesting, even for the conference, after you do such kinds of literature review, at least I could have seen comparing with from the context of Ethiopia, or for that matter, from the context of Africa or something just like that. My other question is, I have seen most of your presentations, and some of even the titles, I couldn't map it from your paper, and I have seen many tables which you are not used in your article. So if you are using such kinds of bold statements in your presentation, it could have been better if you use it also in the paper. Thank you.
Thank you very much for your suggestions. Actually, earlier I knew this presentation was for 20 minutes. And later, and also another thing, seeing to the audience, I thought, let me make this presentation more to the public rather than to the technical people, because this is an ICT Expo at one set. And one more thing you have asked, have I followed any pattern? This is a presentation, of course, for the paper, whatever the rules has to be followed by IEEE. I followed the specifications. For the presentation, just because I wanted the common people also to understand, I did not follow as such any system. And tables are there, yes. Diagrams also are there, yes. My main intention in this presentation was to make the common people understand what is 5G at least. If I talk about the technology, if the time is being given, it's my pleasure to discuss about the technologies. And also I did not conclude also my presentation, as all of you know that. And little more things, how a common person can understand. In that way I've prepared my presentation, to make it simple. I think this has answered your questions.
All right. More questions? Okay.
Thank you. My name is Muhammad Radi. I would like to appreciate the presenter. 5G is not a simple subject. 5G is a very big area, and the presentation is to highlight and to know where 5G is, how it looks like. I think it's a helicopter view which the presenter provided to us. New York University itself, they have organized by a big scientist with so many professors doing on 5G research on millimeter wave. It's not an easy area. Huawei, almost 5 years back, they have invested $500 million. And if you take China, the group, Europe, and South Korea, Japan, 4G America, which she showed to us. It's not a simple area, but it is a very good startup for us to know what is 5G, how it looks like, and what is the next thing is going to come. It's true, it's not easy, and the presenter, we have to appreciate in this aspect to show to us so many difficulties, and the IMT 2020, which they gave it to us as a KPI and everything. I have questions in line with this. It's not a one-man job, even in Ethiopia. It's not a one university job on 5G to do a big research on millimeter wave and massive MIMO and other areas, which I would like also this conference to look into how we are going to gather 5G experts to collect together and somehow for what we are going to introduce as a service. Today, 3GPP is making standardization and specification, and as a whole, 3GPP is third generation partnership, project partnership from ICT. They are doing it, the whole world gathering together, and they are doing it. It is a future technology which is going to come. The standardization is going to be finalized by 2018. It will continue by 2020. It's expected in Japan and South Korea as the leading companies. In any case, what service we are going to include in the specification? My question goes, there are services which we gather together and we can contribute. Today, as the presenter highlighted, it is in the infancy age, and it is the one who's making the standardization. Today, if we talk of 4G, already is finalized, we are going to purchase the product only. In 5G, there is opportunity. There are, I will go a little bit deep in the waveforms, which I would like to ask you. There are UFMC, FBMC, and JFDM. These are the waveform technologies, and which one, how, and the balance and the pros and cons, if you analyze on this one, what we can suggest from our perspective. The second, this is the first question. The second question which I would like to raise is, what is the backward compatibility? You have raised new radio is coming. It's a millimeter wave, and carrier aggregation is going to be there. And for operator which is invested in 4G, and even for LTE advanced, 4G advanced, which we are getting 1 gigabit per second, almost more than that, and backward compatibility. Till today, we are having, if we start with GSM, 3G, wideband CDMA, and the 4G LTE, they are backward compatible. But with new radio introduction, which are talking today in the industry and in the research area, what is your recommendation, or on this one, how we can go together and say to save the capex which is invested by the operator in the third world? These are the two questions. Thank you very much.
All right, thank you. Any other question, maybe? Do you want to do? It will be mine for you. Okay.
First of all, I want to thank our audience, who is really very much educated about 5G. I'm very nice and happy. I just applaud him for the knowledge he's having. But what I wanted to inform you is, you're asking about the capex and the opex of the existing system. Yes, this is a practical situation, especially for developing countries. We just cannot bring whatever looks nice and new for us. There are a lot of other priorities in the developing countries. So what is that? What happened to the things what we have purchased yesterday is something we have to worry about. So when we think about this, millimeter wave technology to some extent is trying to bridge the gap of capex and opex, because your 5G technology can be an extension of LTAA. If you know the technology which has been used for fourth generation is LTEA. So this is, many people are trying to do the research on this particular area, retaining the existing infrastructure of 4G. How can we get into 5G? This is one thing. And the second thing, the first question you asked me, what are the services and what is our role? At the first place, everybody should know what is 5G. If you understand what is 5G, then you yourself will know where you will fit in. This is what was there in my conclusion slide. That is why we need to create the awareness, and still a lot of time is there for the 5G. We can be the players at various levels. It's not that I say exactly you bring from the developed country the technology and fix it over here. If this should be stopped, my sincere advice is we need to have a 5G forum, at least from today, 5G forum in all the universities for ICT through the Ministry of Communication and Information Technology. You make a forum in each and every universities and make students and the academia to understand what is 5G. Then they themselves will advise where our country can fit in and in what technologies we can involve. I think I've answered the question.
Yeah, thank you. No, that was actually a valid question. There are a lot of research going on now in companies like Cisco on how to leverage existing infrastructure to provide 5G services, like what they call the fog, for example, is one area where they could leverage routers that are on the edge to deliver this kind of services. So interesting. By the way, the title of her topic is review. So it is a review. You know, it's not original work, it's a review of existing technologies, and very appreciable. Question? More? Comment? I guess I'd like to thank both presenters, Dr. Tesfaye and Mamata. It was very, very interesting. It's the future, and thank you for coming.
Thank you very much for all of you to be with me to the journey of 5G, and also I thank the ICT Expo for giving me this opportunity. This has been used as a platform to create an awareness only. Nothing more than that I expected. And one of the persons said that there will be around 400 participants. So okay, not disappointing, not empty chairs. We do have some people. And with whoever you're talking, you also talk about 5G, so that let people know what is 5G. This is my request. Thank you very much. Last but not the least, I just wanted to conclude this because I did not show my conclusion slide. I just wanted to tell you, we all have to walk alone if you have to go fast. But if you have to go far, we all have to go together. So this is what is 5G.